Hi there. Today we're going to look at some more at factoring and some additional things that we can do with that. So the first thing I want to look at is some polynomials that might have a higher degree than a quadratic. They're not an x squared, so like number 1 here, it's an x to the 4th. All right, as long as these are set up okay to where the exponents match up nice, we really factor these the same way as we would anything else. Okay, try to ignore my f of x equals. It was the only way I could kind of get this type of a polynomial in here. We're just going to pretend we got this trinomial, and we're just going to try to factor it. The thing is instead of putting in an x and an x, we just have to put in an x squared times an x squared, and that's how you get your x to the 4th. All right, my factors are 35 are going to be 7 and 5. My signs are the same. They're both minuses. Okay, and if you check your outer and inner, there's your negative 7x squared and negative 5x squared. Notice that when I say as long as they're set up okay, that this right here ends up being half of what that is, so that these middle terms end up being the right variable. Okay, and I'll only give you ones that are set up like that probably. Now the one thing you have to watch out for is since these are not necessarily linear, if you factor these, it's still a quadratic, it's possible that this might factor further than what it has right here. In this case, these are not going to factor. Usually it's like a difference of squares that I'm looking to have happen on those. That's not the case here. I'm good to go. There's my factors. Okay, let's try number 2. All right, so in this one I'm going to split it up. Instead of an x and an x, it's going to be an x to the 4th times an x to the 4th, which will work nicely if you'll notice my middle term is an x to the 4th there. All right, looks like factors of 81, probably going to be 9 and 9. The signs are the same, they're both minuses. Now here's an example where these actually are both, they're identical, and they happen to be a difference of squares. That would factor to x squared plus 3, x squared minus 3. But then I could do it again for this one, x squared plus 3 and an x squared minus 3. And these are still quadratic, so they possibly could keep going, but since 3 is not a perfect square, they're not difference of squares, and I'm going to call it quits right there. Okay, why don't you try, actually let me do 3 with you, and then I'm going to have you go turn you loose on number 4. So number 3 is a little bit different because it is a difference of squares. See how there's only 2 terms there? So we'll treat it like a difference of squares right off the bat. And it's an x squared plus 4, x squared minus 4. But since these are still quadratics, they could potentially keep factoring. There's nothing I can do with this one, but this is a difference of squares. Remember that we don't have anything for a sum of squares, so that one's stuck. But this one, I'm going to keep factoring. So I'm going to bring down my x squared plus 4. It stays the same. But this will factor again to an x plus 2, x minus 2. Now I get to be done. Okay, take a minute, pause the video, you try 4 on your own. Okay, so let's look at this. This is one more way that we have to factor, and it's called factor by grouping. We use factor by grouping anytime you have 4 terms here. If you have 4 terms, what we try to do is group these into 2s, like that. Now what you're hoping to have happen, and it doesn't always happen, but if you group them, then you can pull a GCF out of them individually. So in this first group, I could pull out a 3b squared. And then I'd have a 7b plus 1. Plus, and now I'm going to do it again. Pull the GCF out of that group. And so I'd have a 7 with a 7b plus 1. Now, factor by grouping works if you do that, and then what you end up with in these parentheses matches. So basically what you have is you have this big group of something plus this big group of something, and notice that those 2 big groups both have a 7b plus 1. 7b plus 1. So what we do is we basically are pulling out that 7b plus 1, and then we're writing whatever's left, which in this case, the first part would have a 3b squared, plus the second part is a 7. So one more time, what you're looking for is for these to match. So you factor that out and write it here, and then you write your leftover. So there's my 3b squared, there's my plus 7. Okay, I made that nice and cluttery, but that's our final answer. Okay, so let's try that again. Now that one was kind of nice because we had a plus sign right here. It works differently if you have a minus sign. So let's look at this next one. If you have a minus sign, you have to be really careful because the way I put these parentheses in here, if this was a minus sign, all of the sudden it would be subtracting everything in this parentheses set, which would mean this sign would be wrong. If I just stick parentheses in here, it'll mess up this sign. So you always, 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 if this is a minus sign, your very first step is to change that to a plus a negative. And then put your parentheses in there. See if I can squeeze that in. So you always want there to be a plus sign between those. And if it's a minus, you just put the negative on the little 25 or whatever that number is. Okay, so other than that, it's the same deal. Pull out the GCF, looks like a 3b squared, which is going to get me a 5b plus 2. Plus, and now on this one, what I'm going to factor out is a negative 5, which would then leave me with a positive 5b and a positive 2, which is perfect because now these match. So once they match, you write that quantity, and then you write the leftover, 3b squared minus 5. Okay, let's practice one more time. On number 7, oh, it's another one of those that has a minus, so the first thing I'm going to do is change that to plus a negative, and then put my parentheses in there so that there's a plus sign between them. On this first one, I can pull out a 7. No, I cannot pull out a 7. All right, I can pull out an n squared, it looks like, which would leave me with a 7n minus 5. Plus, on this one, I'm going to pull out a, not really anything. But if you notice, remember our goal is to make these match, and right now they don't. The signs are messed up. So what I'm going to do is I'm going to factor out a negative 1, and that'll fix it for me. So now that'll be a positive 7n, and that'll be a minus 5, and that's what I want it to be. So you write that quantity that matches, and you write your leftover. Now, one of the things you should be noticing here is that one of these quantities is squared, which means you might not be done factoring. Now, I was up here. There was nothing I could do with those, but looky here. I got an n squared minus 1. That keeps going. So bring down your 7n minus 5 and factor your difference of squares. Now you get to be done. Okay, pause the video, you try 8. All right, check it out. Does yours match mine? Hopefully so. Okay, we have one more thing to look at. Okay, and this is really the key to why we even bother factoring. I mean, it's like, what is the point? Okay, so here's the point, is a lot of times we have real life situations that we can create an equation to represent. And many times that equation is actually a quadratic equation, and we'll do some of those before the year is out. Today we're just kind of practicing the skill. But if you have a quadratic, and it's an equation, notice now I have an equal sign in here, I'm going to use factoring to solve it. So here's the gist of it. I'm going to just write something down in this corner here. If you think about it, if you take two things and you multiply them, I'm just going to make them up. Let's say it's an A and it's a B. And if you say that that equals 0, the only way that that can ever work is if your A is equal to 0 or if your B is equal to 0, or maybe both. But you've got to have something equal to 0. There's no other number that works for. Like if this was an 8, well, you couldn't say that because A could be 2 and B could be 4, or A could be negative 1 and B could be negative 8. There'd be a lot of options. But if that's a 0, then you know one of those factors, either the A or the B, has to be a 0. So with that in mind, we're going to solve these by setting them equal to 0 and factoring them. All right, so let's look at this number 9. I'm going to take this 3n squared. I'm going to bring the 8n over by subtracting it, and I'm going to bring the 35 over by subtracting it, and that way it's going to equal 0. Okay, so now we're going to do our factoring on this. So let's set up our parentheses. And so you got 3n and n. Factors of 35. Remember, it's going to have to get multiplied by that 3, so you got to kind of think through that a little bit. Probably going to want a 5 and a 7, I'm guessing. That would get me a 15n and a 7n, and one will be positive and one will be negative. I think that's going to work nicely. I want to have a negative 8, so let's make this 15 be negative, and the 7n will be positive, and we've got our factors. Okay, so what's new now is that now these factors are being multiplied here, and they equal 0. And the only way you can multiply two things and equal 0 is if this is 0 or this is 0. So that means in this case that 3n plus 7 has to equal 0, or n minus 5 has to equal 0. So in this case, if I solve for n, I get negative 7/3. On this one, if I add the 5 over, okay, so I have two possible solutions here. N can either be 5 or n can be negative 7/3. And in either of those scenarios, that would make this equation equal. Okay, let's try this again. Let's try number 10. Your first step is to make sure that it equals 0. So I'll have a 49k squared. And you're going to want to put this in decreasing order of your exponents. And so I'm going to add my 28x next, or I guess 28k. And then I'll have my plus 3, and then my equals 0. And this is nice because it's a good practice of our factoring skills. All right, so I'm guessing probably 7k and 7k here. Then it's going to have to be 3 and 1. Looks like my signs are the same. They're going to both be pluses on this one. And so that's going to get me a 21k and a 7k. That works. All right. So now you set each of those equal to 0. And solve. So subtract the 1, divide by the 7. Subtract the 3, divide by the 7. So in this case, I have two possibilities for k. Either one of those values would make that equation work out. All right, I got two more. Why don't you try these on your own? Again, it's a good practice of your factoring skills, but it takes it one step further since it's actually an equation that we're solving. All right, go ahead and pause the video, give it a shot. All right, how'd you do? All right, all four of those were pretty much the same type of problem, and you just have to take it one step further after you factor. So good luck with this.